Alright, the next thing that makes this problem hard is you have to solve two simultaneous equations, which is something I imagine many of you have not done before. So this slide is going to walk you through how to solve the two simultaneous equations you have to solve. Alright, so let's just think about some basic things we know. We know that a displacement we can arrive at by seeing something's velocity multiplied by the time it travels. And we can also take this down to its simpler non-vector form, which you're probably more familiar with. Distance equals speed times time. Okay. And since we're talking about car 1 here, let's go ahead and label all this velocity 1, speed 1. Now, you might be thinking, Mr. Melvin, shouldn't I label that then displacement 1, distance 1, time 1? No. When the two cars catch each other, they will have reached the same distance covered for the first car and distance covered minus 2 for the second car. And they will have done that in the same time. So I'm actually going to keep D and T the same, and that'll make sense when we get to car 2. So let's do that now. Displacement of car 2 is going to be the velocity of car 2 times the time traveled. Alright, now the displacement for car 2 isn't D, it's D minus 2 meters. Okay? And then we'll reduce the velocity to its non-vector form known as speed 2 times time. Now, what we have to do is solve both of these equations. So let's talk about things we know and don't know. We know speed 1 and speed 2. We don't know the distance and the time. So we have two unknowns. There's a rule in math and physics that says for every unknown you must have one equation. So two unknowns requires two equations. Luckily, we have two equations. D equals S1 times T, D minus 2M equals S2 times T. So now we need to do what's called simultaneous solving of these two equations. Alright, when solving multiple equations, the easiest way is to try to eliminate one variable. Now at this point, people who haven't had the upper math classes might be freaking out a little. It's going to be okay. This is meant to be a very hard problem. I'm walking you through it. Alright, so we need to eliminate one variable, and I'm going to do it by a method called substitution. Because I'm solving for D, it doesn't make any sense to eliminate D, so the only other unknown is T. I'm going to try to eliminate the variable T. The way I'll do this is I'll pick the equation that looks simplest, and in this case, the one that looks simplest is D equals ST. The other one looks more complicated. And now in the simplest equation, I will solve for T. So I'm going to divide both sides by speed 1, and now I have T equals distance over speed 1. Alright, now what I'm going to do is take this T that I just found right here, and I'm going to substitute it in for T over here. So this is why it's solving by substitution. I'm going to substitute it into the T there. Alright, you might want to copy down this slide because I need to change to a blank slide to keep things from getting really messy. So anything you need to copy down, please do that, and I'm going to change to a blank slide to keep things from getting messy. Okay, so I know I just said that on this slide I was going to do the substitution, but I realized that I had made hint 2 give you way too much information. So, scroll back after I get done talking, watch the last little bit of that last slide, try to do that substitution on your own. I've told you pretty much everything you need to know physically to solve the problem. At this point, it's just math, which I know is scary for some people. So hint 3 will be walking you through the math of how to solve this problem. Alright, that's all.